Hey everyone, and welcome to this explainer. Today we're tackling a topic that literally every Go developer runs into at some point, toolchain management. Specifically, we're going to unravel the mystery of the permanently stuck Go version and really dig into the hidden power of G-toolchain. You know, if you write Go, managing your environment is just part of the job. But have you ever had one of those days where your machine feels like it's straight up ignoring your commands? We're diving into some fantastic notes from a developer named Ang, who went down the rabbit hole trying to fix a stubbornly stuck Go version. What they found actually reveals the absolute brilliance of Go's built-in toolchain management. So let's solve this little mystery together, shall we?
Okay, picture this highly relatable scenario. You're hacking away on a pet Go project, and you decide it's time to upgrade your environment. Maybe you want Go 1.25x or even the latest 1.26x on your Ubuntu 26.04 machine. So you run the installation. You check the version, it says 1.25.0. Okay, maybe something just hitched. So you try using deeb packages instead. You check again, still 1.25.0. Right, you try manually unpacking the tar files. Still 1.25.0. You even bring in the heavy artillery using an external version manager like Mies to explicitly install the absolute newest version. You run the check one more time, and it is stubbornly, infuriatingly stuck at 1.25.0. It's enough to drive you crazy, right? You're doing everything by the book, but the system is just completely ignoring you.
And this is where it gets genuinely baffling. Ang decided to completely bypass the system path to see what was going on. They called the brand new explicitly installed Go 1.26 binary directly. Just typed out the full absolute path right into the terminal /usr/lib/go-1.26/bin/go version. And miraculously, the output still read Go 1.25.0. No way, right? How can a binary sitting in a folder literally named Go-1.26 run and clean to be version 1.25.0? At this point, it feels like your operating system is gaslighting you. But, as we know, in software there's always a logical explanation, even if it's hiding in the shadows. Well, after rounds and rounds of debugging, the sudden aha moment finally arrived. Ang checked the Go environment variables, and there it was, lurking silently in the config file. The culprit was the Go toolchain environment variable, and it was hard-coded to Go 1.25.0 plus auto. Because this single variable was locked in, Go was intentionally completely ignoring the physical local installation on the machine. It was overriding the whole shebang, silently forcing the use of that 1.25.0 toolchain all along. It's essentially like having a secret set of instructions overriding your steering wheel. To prove this was actually what was happening, Ang put the theory to the test. What happens if you just change that variable? The result is immediate and honestly kind of magical. Ang ran go env w geotoolchain equals go 1.24.0. Instantly, the terminal fired back a surprising message. Go, downloading Go 1.24.0. Without any manual downloads, without messing around with DBs or tarballs, Go completely bypassed the local setup and just automatically fetched the missing toolchain right before their eyes. The huge takeaway here is that this one little variable holds immense power over how your entire Go environment behaves. What we're actually looking at here is a remarkably clever architecture. You see, there's a split responsibility. First, you have what we call the host Go. This is the actual physical binary you installed locally, say using Mies, sitting right there in your local share directory. But then you have the active toolchain, which lives way over in your Go module path. What's happening is that the locally installed Go merely acts as an entry point. It's basically a traffic cop. It wakes up, checks the rules, and then completely delegates the actual heavy lifting, the compiling, the standard library, all of it, to the active toolchain it pulls from your module path. Let's actually break down this brilliant handoff step by step so you can see the gears turning under the hood. Step 1, you run a standard Go command in your terminal. Step 2, that host Go binary wakes up, but before it compiles a single line of code, it checks your Go toolchain variable and your project's go.mod file. Step 3, if it realizes you don't have the required toolchain version, it dynamically downloads it for you, treating it just like any other module. And finally, step 4, the host Go steps aside and seamlessly delegates all the compilation and tooling to that newly downloaded active toolchain. It's a beautifully elegant system. Now, this isn't just some quirky little feature. We are talking about a fundamental philosophical shift by the Go team. They intentionally moved away from the old, rigid, system-managed model, the one where you just have to pray that your global system installation happens to match the specific project you're working on. Instead, Go has fully embraced a project-managed model. This means your toolchain version is defined and managed seamlessly per project. It's a completely integrated, batteries-included approach that frees you from the absolute nightmare of juggling conflicting Go versions across your operating system. And the beauty of this is how incredibly simple it is in practice, especially if you're working on a large team. All it takes is one simple line in your go.mon file. Just write Go 1.26.3. That's literally it. By defining the version right there in the project files, Go automatically standardizes the development environment across every single developer machine and build server. You only need a base host Go version installed somewhere on the system, and the compiler handles the rest. Imagine onboarding a new developer. They just pull the repo, run a command, and Go guarantees they are using the exact right compiler version. Zero extra configuration required. When you start treating the compiler as a distinct module dependency, the benefits are absolutely massive. First, like we just said, it effortlessly standardizes development across your entire team. Second, it requires absolutely no root or sudo access to switch compiler versions, because the toolchain safely downloads right into your local user's module path. Third, it prevents those nasty conflicts with system scripts that might be relying on whatever ancient version of Go your operating system originally shipped with. And fourth, and this is absolutely crucial for modern development, it ensures verifiable module security. Because the toolchain is treated exactly like a code dependency, it runs through a checksum verification to guarantee it hasn't been tampered with. It's a total game changer. I really love this quote from Ang, the developer who originally documented this whole journey. They wrote, "Of all the tech stacks I have tinkered with, Go's approach of modularizing its toolchain is the best. It's truly a batteries-included experience." Ang even pointed out how great it would be if other languages like Elixir or Erlang adopted something similar. But Go has a distinct advantage here. Its unique architecture, the fact that it compiles down to a single cross-platform binary, makes it uniquely equipped to pull off this seamless magic trick. The language literally manages itself.
Which brings us to our final and maybe most provocative thought for this explainer. Is it finally time to ditch your external version manager? I mean, we've relied on tools like ASDF, Mies, or NVM for years to wrangle our tech stacks. But what we've discovered today is that Go is fully capable of driving its own car, so to speak. These built-in tools effectively make external managers completely obsolete for Go developers. It's efficient, it's highly secure, and it's baked right in. So, the next time you're setting up a fresh Go environment, will you still reach for that external manager, or will you just let Go take the wheel? Thanks so much for hanging out with me for this explainer. Keep learning, keep building, and I will catch you in the next one.